Sir, I have the honor to present to you the summary of my work entitled Study of the Magnetic Structural Property of CuO Only. Here I have my work then containing as follows. General introduction. CuO copper oxide is a semiconductor based on metal oxide. CuO layers have been deposited by several physical and chemical techniques such as vacuum evaporation spraying. Among the applications of CuO solar cell photocatalysis. Copper oxide. Formation of different types of copper based oxide are listed as below in this chemical reaction. Cupric to oxide in mineral form known as generate in the natural state of formula CuO. It is also in the form of a dark gray or dark black powder as shown in figure 1.1. Table 1.1. Group together some chemical and physical properties of cupric oxide CuO. Crystallographic structure. CuO is characterized by monoclinic crystal structure, its lattice parameter. The application of then layer of copper oxide. Here we will cite various applications of CuO. 1. It's important nanoparticle for the formation of additive by lubricating of the oil. Catalysis for hydrocarbon, photoconduction and manufacture of lithium-ion battery. Phase diagram. Concerning the phase diagram, the CuO system has many distinct phases, but only two are thermodynamically stable. These are CuO and CuO, which are compound exhibiting a near zero deviation from stoichiometry as illustrated in figure 1.4. Moreover, the solubility of oxygen in copper is almost zero. Application example. For Article 1, experimental detail. Study of the morphological composition of the sample. Phase study of sample. Quantitative analysis of the phase of the diffraction grain. The use of databases to identify X-ray spectra. Carrying out magnetic measurement. For instrument GEOR GEM 2100 transmission electron microscope. X-ray diffractometer D8 magnetometer MPMS XL5. Result. Figure 2.1 show the high resolution transmission electron microscope image of the CuO nanoparticle as shown by the result. The powder obtained are strongly agglomerated spherical particles. The size of the particle varies from 5 to 20 nanometers. The nanoparticles obtained are characterized by a high surface energy. Since the synthesis of nanoparticles in plasma. Chemical reactor chemical processes always take place with the predominance of layer by layer growth of nanoparticles due to absorption of atom and division processes. Atomic mass transfer to the interface. Figure 2.2 show the characteristic of the shape of X-ray peaks indicated the presence in the nanoparticle of two fractions of different size of crystality. This conclusion was made on the basis of the fact that with a large integral width, the diffraction maxima had abnormally peaked. Such a complex shape could be explained only by the superposition of two peaks of significantly different weight. Figure 2.3 show the dependence of the magnetic moment for the nanoparticle obtained at different precipices of the gas mixture. On the basis of observed behavior of CuO nanoparticle, it can be concluded that the magnetic property of the system under study are related to the amplitude of the residual stresses in the nanoparticle. Article 2. Experimental detail. Deposition of CuO films by reactive direct current sputtering of a copper target and glass and silicon substrate. 100. The study of the structure of films by X-ray diffraction. Magnetic measurement. Instrument. Alcatel SCM 600 spray system. Directs D8 advanced vibrating sample magnetometer EV7 VSM. Result. Figure 2.1 display the DRX pattern of copper oxide dye film deposited on the glass substrate with different oxygen flow rate 16, 20, 25 and 30 standard cubic centimeter per meter depending on the oxygen flow rate. The deposited films exhibiting different copper oxide phases when the oxygen flow rate is fixed at 16 standard cubic centimeter per meter. A pure CuO phase was formed which agrees with the GSPDS card at an oxygen flow rate of 20 standard cubic centimeter per meter. The RDX diagram shows the presence of an intense peak close to 36.58 degree, which can be attributed to the reflection 111 at the cubic phase CuO. Direct analysis confirmed the presence of cubic tetragonal and monoclinic structure CuO, CuO4O3, CuO films respectively. Figure 2.2 The magnetic moment as a function of the magnetic field. It can be observed from Figure 2.2 that the magnetic property of copper oxide film are strongly influenced by the flow of oxygen, which are the shaped hysteresis. Lobe indicate that film deposited at 16 and 20 standard cubic centimeter per meter oxygen flow, showing poor ferromagnetic behavior with a diamagnetic compound, while film grow under 25 and 30 standard cubic centimeter per meter reveal a dominant diamagnetic compound on G side, very low ferromagnetic behavior in the low K range. It is clear that with the increase in oxygen flow, the ferromagnetic behavior decreases. General conclusion. Finally, for the conclusion, our study focused on the magnetic structural property of CuO copper oxide, although which aim to the CuO has a monoclinical crystal structure. Regarding the first article, problem associated with the bifurcation of magnetization curve during cooling in zero and no zero magnetic field, behavior of no equilibrium, reaction of magnetization and magnetic viscosity CuO nanoparticle. Regarding the second article, the magnetic properties are strongly influenced by the oxygen flow. The ferromagnetic behavior is degraded due to the formation cancellation of oxygen vacancy. Among the advantages of CuO, the availability and abundance of rare materials and no toxicity, low production cost, high refractive index and excellent stability. Thank you for your attention.